So today's session is going to be a session on, we're going to continue our ongoing discussion that we had in the last session. So let me begin with a presentation. I will be starting with presenting the screen so that we know. Yes, so first, since we know we are on Swiflearn platform, so we have to know and understand about this particular platform. It is the most sincere learning destination where we have classes right from grades 3 to 10. So this is something which is very, very good about Swiflearn. It is 100% live and interactive class. We can actually customize our class also if you want one-on-one, just one student with a teacher or a mentor, or you can have a maximum of 6 students in one batch. So you can understand we are getting personalized attention. So maximum students is just 6. Isn't that good? We also have a very dedicated academic mentor team, which will track the entire progress of the student. So you will get regular updates about your progress, parents too. And it covers the syllabus as per the school exam schedule. So you are not left behind anywhere. You are with the school as far as the portion is concerned. So every care is taken. And the key features is detailed progress reports are given regarding the students' progress to the students as well as the parents, so you know where you stand and you can actually chart your progress through the months or through the various sessions that we are having. We also have Swiflearn academic test series, call them as the SATs. So that also gives you a good idea to assess yourself as to where you stand. There are unlimited practice tests that you can take. Subjective tests are also available so that you can prepare yourself well before your exams and you know exactly where you stand. So this is a very, very good platform for that. And for this, the best thing that you can do is subscribe to the Swiflearn channel, press the bell icon so that you can get all the updates whenever any one of the teachers are coming on live to give a very, very good session, just like me. So just have to press the bell icon, share, as well as like and also comment. This is very, very important so that if you have any doubts, they will be cleared. Don't worry. So everything will be taken care of on this wonderful platform. So shall we begin our session today? We are moving on to the second session. If you remember, last session I had dealt with gravitation. It was part 1. If you remember, we had talked about the universal law of gravitation. We had discussed about capital G, that is the universal gravitational constant. We had derived the value of small g, acceleration due to gravity. We had discussed what exactly free fall or a free falling object is, what happens, what is the gravitational, Earth's gravitational pull. We had talked about two objects or two bodies in the universe, how they attract each other, how it is dependent on the mass, and we had also derived a formula for the force of attraction between two celestial bodies or bodies in the universe. So we are moving ahead with our discussion on gravitation with our next session, that is gravitation part 2. So let us see what does this session have in store for us and what all are you going to learn today. So let's begin with our session. So today, what are the things that we are going to discuss about and what are the things we are going to learn? Right, we are going to talk about mass, weight of an object on the moon. Yes, this is something, moon has always held our fascination. It's an object of fascination and romanticism as well. If you know about that, yes, it is our natural satellite of the earth, and we have actually wondered and watched in awe when man has actually gone on missions to the moon and stepped on the moon. So yes, we are going to talk about that because we have vivid pictures of all the various videos that we have seen of man's stepping down on the moon. So yes, we are going to talk about the weight of an object on the moon, and we're going to discuss about that in today's session. We're also going to talk about a concept of thrust and pressure. So today's lecture is also going to be very, very interesting. So let us start the lecture. So as we said, we're going to discuss about mass. So whenever we know that matter is a substance that has mass and occupies volume. So a simple thing is every body has a certain amount of matter in it. We know this. Each and every body, right from a small pin to a big ball, right? Everything. So what do we call this quantity of matter which is present inside the body? Sets you thinking, right? Yes. So what is this quantity of matter? That is mass. So when we define mass, we say it can be defined as the quantity of matter present inside a body is its mass, right? And what will be the SI unit of mass? It is always kilogram. Can you look at this figure? This is the instrument that we use for measuring mass of any object. Unit of mass is kilogram, kg. So when we talk of the mass of a body, it is the measure of its inertia. What is inertia? If you remember Newton's laws of motion and Newton's first law, it exactly talks about inertia, right? So it is the inherent capacity or the property possessed by a body by virtue of it. It does not bring about a change of rest or in motion. It does not want to bring about. That is what we call as inertia. So when we talk of mass, we compare it with inertia. Greater the mass of a body, greater will be its inertia. A simple thing, if there is an elephant at rest, to move that elephant or to make it actually move, so much of force is required. So you can understand, more the mass, more is the inertia. This is one thing we have to understand, where we are trying to connect mass with inertia. Also, another point that we have to remember is that the mass of an object is constant. Wherever you go on the earth, you might be at the poles, at the equator, it will remain the same. There will be no change in the mass. So no change from place to place. Wherever you go, mass of a body is going to remain constant, right? So let us learn more about this mass. Okay, so when we talked about mass, we talked about it being the quantity of matter possessed in a body or present in a body, right? So now we are going to learn about weight, and we are going to actually understand these two quantities or entities, and we'll try to see the difference. यानी mass क्या है और weight क्या है? So all along we used to always assume mass and weight दोनों एक ही है. नहीं, there is a difference between it. So today, let us learn this difference between mass and weight. Okay, look at this. I'm having an apple, right? And we are actually weighing it on this particular scale. Can you see? Yes. So the force with which the body is attracted by the earth is known as the weight of the body. So these are two different things now. Are you understanding this? And I had talked about mass. We talked about it is the quantity of matter present in a body which is going to remain constant. How much of matter is there? That gives the mass. More the matter, more the mass. Less the matter in that body, less will be the mass. But when we talk about weight, there is something which we are considering here. The force with which a body is attracted by the earth is known as the weight of the body. So what has been included here when we talk about weight? This particular force that is attracting the body downwards. And what is that force? It is the Earth's gravitational force, exactly. So when we compare the mass and weight of a body, mass is just the quantity of matter. There is no force acting on it when we talk about mass or when we calculate mass. But when we talk of weight, yes, there is the Earth's gravitational force, which plays a major role when we actually weigh any body or measure the weight of any body. Yes, this is something which is starkly different between the two, right? Okay. So From this, what did we conclude just by going through the definition? That the force with which the earth attracts a body towards itself is called the weight. So we understand that weight depends on where the object is. That means if the weight of the object on the earth will not be the same as its weight on the moon. Simple understanding, because everywhere the gravitational force is going to be different. And when we talk about weight, we said, yes, there is going to be presence of the gravitational force. So when gravitational force will change, weight is definitely going to change. So it cannot be the same as in mass. Mass remains the same everywhere, does not change from place to place. But when we talk about the weight, yes, gravitational pull does come into it. All right. One other thing that we have to understand is, yes, I am having students here, right? Hello to everybody. Yes, good to see. There is Kumar, Suraj, and hello, Lokesh. Yes, good to see you all. And it's good that today we are actually going to talk about, as we have discussed already, we are going to talk about the difference between mass and weight. So when we talk of weight, because there was the addition of the gravitational force, so the formula will be weight equals to, that is W equals to mass into G. So here, along with mass, we are also having addition of acceleration due to gravity. So we know that the value of G, small g, on Earth is 9.8 meter per second. This we had second squared. We had already discussed this yesterday and actually derived it also, right? So yes, we know it. It's a fixed value. And remember, SI unit of weight is Newton, right? So 1 Newton will be 1 kilogram meter per second square. So how was this derived? When I'm talking of weight, it is mass into G, that is acceleration due to gravity. So mass SI unit is kilogram, right? And G is meter per second square. We have already done that yesterday, right? So weight becomes kilogram meter per second square, right? So now let us actually get into the difference between mass and weight. So again, please understand, mass SI unit is kilograms, weight SI unit is Newton, or you can also take it as kilogram meter per second square. Yes. Hello everyone. I hope you all are getting this concept now. So now let us try to compare mass and weight. So the differentiation or distinguishing characteristics between mass and weight, right? So when we talk of mass of a body remains constant, we said, because whichever place you go, wherever you go, it is going to remain constant. But weight of a body will change from place to place. So mass of a body can never be zero. It will never be zero. But weight can be zero. Where? At the center of the earth, because there G is going to be zero. Come to the center of the earth, it is going to be zero. So whatever mass is going to be there, your mass, you multiply it by zero, it is going to be zero. This is another thing that you always have to remember. Also, mass is a scalar quantity. So there is just magnitude, no direction involved. But weight is a vector quantity. Why? Because we are talking about a force acting downward. So yes, direction is involved along with magnitude. So weight becomes a vector quantity. This is a wonderful point of differentiation. This is how you have to always remember. You also know SI unit of mass is kilograms, right? And that of weight is Newton. We have already discussed this as well. Okay, mass, the instrument which you're going to measure mass with is a beam balance. So you have a beam with two pans. So you will try to see to it that the two pans are at the same level, right? So I hope you all are understanding the beam balance. There's a beam through which there will be two, you can say, strings, and there will be two pans. keep the weight on one side, and the mass of the, the object that whose mass you're going to calculate, that will be kept on the other panel. And when it will be at the center, the pointer, that will tell you that yes, both the masses are equal. It is balanced. So then you can actually calculate or measure the mass of that particular object. Very easy. Weight is measured by using a weighing machine or a spring balance. So here what is happening is spring balance, right? There will be a spring inside and there will be a pull on it, right? You're suspending the object that whose weight you're going to measure on it at the hook, and it will get stretched, right? Because there is the gravitational pull on that object, as a result of which whatever value you're getting on the scale is going to be the weight of that object. So can you understand the difference? Or on the weighing scale, when you stand on the weighing scale, and what are you actually doing? You're standing on the weighing scale. So what is happening is your mass is having a downward pull by the gravitation or gravitational force of attraction from the earth. So what is happening is your mass multiplied by g, you are actually measuring your weight. So this is how you have to actually understand how mass and weight are different. All right. So now let us talk about weight of an object on the moon. You see, the weight of an object on the earth, we have talked about, it is the gravitational pull, right? The force of gravitation, which is pulling the mass of the object, attracting an object towards itself. So G, small g, comes into the picture or comes into play. But when we talk, so the weight of an object on the moon will be the force with which the moon attracts that object. And we know that the gravitational force of attraction on different planets is different. Have you ever seen the astronauts who have gone on the, you must have seen video clips, right, of astronauts on the moon. Have you seen them? They are actually jumping. You can see, like, or in space, you will always see them. They are floating in space. Absolute state of weightlessness in space. That is because there is no gravitation in the space. So that is why you are absolutely weightless, and so you're floating. So when we come back to the moon, we know that the moon also will attract. So can you see the difference here? Weight on the earth is 730 Newton, whereas the weight on the moon is only 121 Newton. So there's always a joke that goes around that I am not fat, I'm just on the wrong planet, right? If I would have been on the moon, I would have been very, very light. Okay, so this is on a lighter note, but yes, this is exactly what we are talking of. So from planet to planet, because the value of G changes, the weight will also change. So since we are going to discuss about the moon, that always holds our attention, let us talk more about it. Yes, weight of an object on the moon. Moon, we know, if you compare with the Earth, it is a satellite, the natural satellite of the Earth, right? So it has definitely less mass than Earth. So the gravity also, small g, associated with it will also be small. You're getting this? So it is going to be lesser. The value of g, the force of gravity or the attraction due to gravity is going to be lesser because the mass of moon is lesser as compared to the mass of the earth. This is one concept that you have to understand and try to relate the things. So if you remember, we had talked about value of small g is capital G, the universal gravitational constant, which is going to be constant, multiplied by the mass of that particular planet upon r squared. So if you remember, mass does play an important role here. So we already know weight is equals to m into g. So weight on the moon is going to be less because g is less. M is going to be the same everywhere. Understand this. Mass will be the same, even if it's on the moon, let it be on Jupiter or any other planet or on Earth, it's going to be the same. But because the value of g here is changing, weight will change. So weight on moon will be less because the value of g is less. So you're going to weigh quite less on the moon. We'll talk about that. How much less are you going to weigh on the moon? Earth has more mass than the moon. Yes, in comparison, if you compare the Earth and the moon, yes, Earth has more mass. So its gravity G also is going to be more. So that is why weight on the Earth is more. If you remember the earlier figure, we had actually compared the weight of a person, of that lady, on the Earth and on the moon. And you can actually see the difference in their sizes as well. Mass, right? So Earth has more mass, more value of G, as a result of which it is going to show we are going to weigh more on the Earth as compared to the moon. Right? This is a lovely concept. So we have to understand weight of an object on the moon is 1/6 of your weight on Earth. If a person weighs, say, 48 kilograms on Earth, that is the mass, okay, just divide it by 6, you will weigh only 8 kilograms on the moon. Good, isn't it? So very light. All right. Let us move ahead. Weightlessness. Yes, this is a concept where you will not feel, because there is no G coming into the picture, small g, acceleration due to gravity or the force of attraction due to gravity, right? Yes, all right. So when we talk of weightlessness, yes, Reena, nice, good to see. Gautam Patidar, yes, welcome. So you all are right on time to learn about weightlessness, right? So we have to understand, you must have seen so many movies and videos of astronauts in space, right? So many space missions also. Have you seen the astronauts in space? They feel so weightless. They're actually floating right in space. कितना अच्छा feeling है. But why? Because there is no gravity in space. So the G, value of G doesn't come into play at all. So your weight is 0. I would say that would be the best place for me. I would love to be in space, right? You'll be absolutely weightless, right? Okay, on a lighter note. So let us go through some question answer session. So let us answer these questions, right? I hope all of you all are ready. Reena, Gautam, Kumar, Suraj, Lokesh. Yes? So let us go with the question. Question is, write the equation that shows the relationship or relation between weight and mass of an object. So we are going to talk about an equation which is going to connect weight and mass of an object. All right, we already know this. We have done this, yes. So this equation, which is going to connect or show a relation between weight of an object and mass of an object, is W equals to M into G. Okay, so that is how things will go. So let us move ahead to the next part. Yes, the next question, be ready for it. Let us go through it so you can also see the question and answer it also. The mass of an object is 20 kilograms, right? 20 kgs. What is its weight on Earth? So here we are having M, value of M equals to 20 kg. We know the formula of weight, right? W equals to M into G. And the value of G is fixed. We already know that. We had actually derived and calculated it in the earlier session. So we already know it is 9.8 meter per second square. So what are we getting? 20 into 9.8. That works out to 196 Newton. So these are the kind of numericals. So you should be knowing the formula and just apply, just substitute. Of course, pay attention to the units as well. If it is given in grams, convert it into kilograms. So you should get it as kilogram meter per second square, or you can write it also as Newton. That is the SI unit of weight. Fairly simple, very easy numericals and calculations. Right, another question. How is the weight on the Earth? Yes, there is Divyanshi. Hello. Okay. So Divyanshi, I hope you have, you are, with the lecture and you have been going through the lectures. If you just joined, We are discussing, this is the second session on gravitation. So we're just answering a few questions. How the weight of an object on the moon varies with respect to the earth. So they are trying to ask us what exactly is the difference between a person's weight on earth and a person's weight on moon. How is it going to vary? How is it going to be different? Okay. The weight of an object on the moon will be 6 times less. Yes, we have talked about we weighing less on the moon, right? So yes, it is going to be 6 times less than the weight of an object on the earth. This is how we are going to connect these two things, weight of an object on earth and weight of object on the moon. This is the relation. So if I have to find out weight of an object on the moon. I already know the weight of the object on earth. I just have to do 1 by 6 into the weight of the object on earth. I will be able to calculate weight of that particular object on the moon. So fairly simple. Okay. Another question. An object weighs 20 Newton when measured on the surface of the earth. So we are having weight of an object on earth. What would be its weight when measured on the moon's surface? So we already have a relation how we are going to connect the weight of an object on the earth with the weight of object on the moon. So if I have to find out weight of the object on the moon's surface, that is equals to 1 by 6 into the weight of an object on the surface of the earth. So we already have that value. So what are we going to do? We know weight of the object on the moon is 1 by 6 into weight of that particular object on earth. So it is going to be 1 by 6 into 20, that is 3.33 Newton. Can you see the difference? Yes, right. Very easy. It's very easy to solve these questions. Yes, a common question asked to differentiate or show the at least 4 differences between weight and mass. We have already discussed these. We'll just go ahead with the, okay. Yes, so first thing, mass of a body always remains constant wherever you go. It doesn't change as you move from place to place. Weight of a body definitely changes from place to place. Yes. Second differentiation, we have to list 4. So we are going on to the second. Mass is a scalar quantity. That means it is described only with magnitude, whereas weight is a vector quantity. There is magnitude as well as direction involved. So it becomes a vector quantity. Right, I hope all of you all are getting an idea of this. Third point of differentiation, unit of mass is kilogram. Unit of weight is Newton. We have already done this also. Mass, the instrument of measuring, mass is measured by a beam balance. Weight is measured by a weighing scale or a spring balance. Yes, so easy. Things become so easy when the concept is very clear, right? Okay, good. So now let us discuss some other concept. Have you ever wondered why cutting tools like the knife, many of you all work in the kitchen, help your mom in the kitchen, right? So when you have seen that the knife always has sharp edges, we always prefer it to be sharp. Why? Why a truck or a motor bus? Have you ever seen? You will see it has got wider tires. Can you see this? Yes, wide tires. They look very huge, right? And in comparison with you say a car, right? If you see, the tires of a truck are more wider. Why is this? To know the answer, why cutting tools have sharp edges and why a truck or a motor bus has very much wider tires, we have to discuss about 2 concepts, thrust and pressure. And that is exactly what we are going to talk about. Thrust, can you see this? There's a stationary surface and a hammer is hammering on the nail. So there is a force being exerted on the nail. And can you see it is moving perpendicular to this surface? Can you see this? The surface is stationary. It is a table or maybe a log of wood. I am actually taking a hammer and hammering it on this nail. It is going downwards. A force is being exerted by me on the nail. So what is thrust? We come to the idea or the concept of thrust It is the force applied on a surface in a direction perpendicular to the surface. So can you see this? Exactly, this hammer is exerting a force on the nail, and how is it moving? It is moving perpendicular at 90 degrees to the surface. So this is exactly what we mean by thrust. Okay. So we know thrust is nothing but the force being applied. So its unit is going to be the same as the unit of force, and that is in Newton. Okay. So let us learn about the concept of, yes, I wish I could. I will try, right? Hello, it's Anugya Chauhan. Hello to all my students. I hope you are getting a fair idea of the topic, right? We can have doubt solving sessions also in the coming session, so where all your doubts will be cleared. I am great, Anugya. Lovely name. Yes, I am great. Thank you so much. Okay, I hope all of you all are also safe and very, very good considering the present times, right? So it's very good to see many students attending. Very nice. So we talked about thrust, about a force which is exerted perpendicular to a surface, right? So yes, hello, Avinav Singh. Good. Very nice. And hello to you too. Right. We're talking pressure now. The second concept that we are going to, which is going to connect the thrust and pressure. So pressure is nothing but thrust upon area. So this is how we are connecting these two concepts of thrust and pressure. Okay, so how would we define pressure? Pressure is the effect of thrust per unit area. Now, if you look at this particular formula, right, if you can see this, you can see how is pressure related with thrust. Thrust is nothing but your force, and how it is related with area. Let us talk about that. The unit of pressure is Pascal. You can also write it as Newton per meter square, because unit of SI unit of thrust, it's nothing but force, so it is Newton. Area is square meters or meter square, either way. So 1 Pascal is nothing but 1 Newton per meter square. I hope you all are getting this idea, right? We're going to discuss, I want you all to remember this particular formula. Pressure equals to thrust upon area, because we are going to discuss further based on this idea. All right. So now we are going to talk about dependence of pressure on various factors and how it influences, because our question is still not answered, which we began when we just discussed about thrust and pressure. We talked about sharp knife edges. We talked about the tires of trucks and buses being very wide, right? So this is what we are going to now discuss. It is going to answer our question, our query. Pressure depends on two factors. When we say pressure equals to thrust upon area, so definitely there are two entities on which pressure depends, right? One is the force or the thrust, and the other is the area, right, on which it is acting, right? So can you see this? This is a force of 12 Newton acting on this particular hammer. And here we have a force of 20 Newton acting on a particular hammer. So you can see force here is going to be more when it is 20 Newton. Just waiting for you all to get an idea about this. Yes, can you look at this, children? You can see at one side you're having a 12 Newton force acting on this nail, and here you're having a 20 Newton force acting. Definitely force here is more, right? So pressure, you can see which one, which nail. I just want to ask you all, if you all can, you can put in the comments, which nail will move faster into the wood surface? Can you all just comment? Just by looking at this figure. I'm just waiting for a couple of seconds, so then we can proceed. Also, I would love to, if you all would really comment, so that I can understand that, yes, you all are understanding this concept as far as pressure and thrust or force is concerned. I hope you all would all comment. Okay, let's move ahead. Yes, superb. Yes, Avinav Singh, very happy. You have actually answered this right. So on the 20 newtons, and the second one. So more the force, more will be the pressure. So what is the correlation between pressure and thrust or force? They are directly proportional. More the force I will apply, more will be the pressure being exerted on that particular object. Understand this, a direct proportion, because we said pressure equals to thrust upon area. So pressure and thrust or force have a direct proportionality. Yes. So what about area then? Can you see in the first figure, you are having the pointed end, pointed part of the nail entering into the wood. And here you are having, can you see the rounded portion, the head of it? So it is going to be a more area. So now you tell me, where will be the pressure exerted be more? You all can comment, not a problem. You all can also think and answer. Yes, come on. Let's answer your question. Yes. More the area, less will be the pressure. So here pressure exerted, can you see, is less, because here area in contact is more. So pressure will be less. So what can we conclude from this? The relationship between pressure and area is inverse relationship. More the area, lesser will be the pressure. Lesser the area, more will be the pressure. Whereas pressure and force have a direct relation. More the pressure, more the force, more will be the pressure. Less the force, less will be the pressure. So it depends on these two factors. Yes. So now we are going to try to correlate it with our particular discussion that we had, or the question that was asked. So everyday observation. This is something which is very much up your alley, because you all are school going children, right? Though this year, this was not much possible, but yes, have you seen the school bags that students carry? They have wide strips. Can you see the handles, the strips which are go over the shoulder? They are wider. Why is this? So more area in contact. So it distributes the weight over a large area of the shoulder. So less pressure is exerted, because we know pressure and area have, yes, this is Zoom, but we are live on YouTube, right? Avinav, I'm just answering your question because you are asking this, right? All right. So when we talk about these wide stripped bags, basically the straps being wider, area in contact with your shoulder is more, right? As a result of which, because it is inverse proportion, it is the pressure exerted by the heavy bag because of the books on your shoulder is reduced. So isn't that good? Yes. Knife. This answers our question. In case of a sharp knife, the force of our hand as we are using to chop or to cut falls over a very small area of the object, producing a larger pressure. So what happens is, when the knife edge is sharp, the area in contact is lesser. So as a result of which, what happens is, as you are cutting with less pressure, you are able to cut faster. So your work is fast, work is efficient than if you would have a blunt knife. When a blunt knife, the edge is a little more rounded and more thicker. So area in contact is going to be more. So you have to actually, yes, Aryan, hello, hi. Yes, the lecture starts at 7. If you all could join at 7, it would be wonderful. So you all can, sit through the entire lecture, and learn many different things, right? So it would be really good. We have lectures from starts at sharp 7. So if you all could join at 7, it would be so good, right? Wonderful slides we have here with beautiful animations, which can make your concepts really clear. All right. So this is the concept when we started with talking of a sharp knife and a blunt knife, if you remember. So this is exactly where we are using this concept of pressure and area in contact. Okay. Now we'll talk of the tractor. The other question that we had, tractors also have broad tires. Now, why? Because they are on the ground, on the fields. A tractor is moving on the fields. The ground there is more softer. If these tires were little narrower, what would have happened was the area in contact would be less, as a result of which pressure exerted by the tractor would be more on the ground. It would sink very easily into the soft field and it would not be able to move ahead and do its work. So by adding these or putting up wider tires out here, what is happening is area in contact is more, as a result of which the pressure exerted by this entire vehicle on the soft ground is lesser, because we know area and pressure have an inverse proportion, right? So inversely proportional, so it becomes very, very easy to understand this concept. So this is exactly answering our question, because we talked about thrust, we talked about pressure, we talked about the factors which connect or on which pressure depends, a direct proportionality of pressure with the thrust or force, more the force, more the pressure, and inverse proportion of pressure with area, more the area in contact, less is the pressure, less the area in contact, more is the pressure. So this is how exactly, if a person, a lady wears, pencil heels, we call them as stilettos, the area in contact is very less. So that is why after a person, lady keeps standing for a long time, you can actually feel the pressure and the pain on your calf muscles. But if you wear those wedge heels, the broader ones, area in contact is more on the ground, as a result of which it becomes very easy. You can stand for hours together. Yes, so yeah, here we go ahead. Yes, so that is why they use this concept exactly when they actually build dams. Now, when we're talking of dams, the base of the dams is always broader. The foundation is always larger or broader. Why is this? Because water in the reservoir will exert pressure. It always exerts pressure. So as a result of which, what will happen, if the area in contact, the foundation is broader, it becomes a very sturdy structure. It will be able to withstand, because more the area, it will be pressure exerted will be less, as a result of which it will be able to withstand the pressure of the water. Simple. Foundations of dams and buildings, tall high rises always have broader pillars as their foundation. It's on a larger area of contact is more. So pressure of those tall, big stories high up is lesser. Otherwise, the entire building will just sink down. Dhas jayega zameen mein. So that is why it is very important. So these are the concepts where application of the idea of pressure and force and area comes into play. So let us answer a few questions. When standing on loose sand, why do the feet go deep into the sand? Must have gone to the beach side, right? The seaside, and stood on the shore. And when you're walking on the sand, even people actually go for a jog or a run on the beach side. This is basically because our feet actually go deep into the sand. But if you're lying down on the sand, the body does not go that deep into the sand. Now, why is this? Let us think. We have just discussed about certain factors on which pressure depends. So here goes. The solution is, when we are standing on loose sand, what happens is the force acting is going to be the weight of the body, which is going to act on an area which is just equal to the area of our 2 feet, right? This area of our feet and the entire weight of the body, you can imagine, is definitely, the area is very less as compared to the weight acting on it. So definitely pressure felt will be more, and that is why our feet sink deeper into the sand when we are standing on it. Now, when you're lying down, what happens is, can you see the area of contact? It's a wider area as compared to our 2 feet. So when we lie down on the sand, in this case, what happens? The weight, that's the same person. So weight is the same. That is not changed. Weight or the force acting downwards. Right now, in this case, it is a force that we are talking of. That is the same. The person is the same. So it's going to remain the same. When you see the area of contact, however, it is more as compared to the 2 feet. So whatever is in contact is much wider, much more than just the 2 feet. So area of contact of the whole body is greater. So as a result of which, the body will not sink deep into the sand than when if the person would have been standing on his, yes, Shreya, yes, Exactly right, Shreya. You have come up with the answer. I was a tad bit late because I was explaining this concept, but yes, you are very right. Shreya, correct. Good. I'm happy to see all of you all are actually, participating in this. I'm very happy. All right. So let us answer another question. Let's see. Foundations of dams and buildings are laid on a larger area. We had discussed this also when we explained the concept of pressure and area. So yes, let us answer this. Foundations of dams and buildings are laid on a larger area. Basically, we want to increase the area because we know area and pressure have an inverse relation, right? So pressure is force upon area. So greater the area, lesser pressure. So dams are much safer. Otherwise, there's every chance that the dam might burst, right? Yes, Avinav? All right. Okay. Yes, so what all? Let's have a quick recap. And Sarita, hello. Good to see that you all have joined. I would love it if you all would join at 7 o'clock sharp, so we can learn many things and discuss so many other concepts. And, it is a good thing for you all also. You all can also, आप भी क्या क्या जानते हो कितना जानते हो all can answer in the comments. It would be super, right? Very nice. So, all right, Sarita. So it is good that you have also joined. So today's session, what all have we learned? Let's have a quick recap. We talked about mass. We talked about weight. We tried to see the difference between mass and weight. We talked about weight of an object on the moon. So here I joked also. Yes, Avinav. Yes, we joke. I did joke that we are on the long planet. It's not that we are heavy. Yes, yes. I'm so happy, Avinav. I will be there on alternate days at 7 o'clock. So you can definitely join. All right. And we also discussed about thrust and pressure. So we talked about the force acting perpendicular on a surface. We talked about pressure, which is nothing but the thrust or force upon area. So these were the things that we discussed, and we actually saw the applications of these in our everyday life as well. When we talked about a sharp knife, we talked about the foundation of dams and high-rise buildings having broad bases or broad foundations. We also talked about the tractors having wider tires. Yes, so definitely these things are the application of the concepts of physics which we see in our everyday life. So even when if we talk of driving a nail into just why nail, even when you have to put some chart paper onto your whiteboard or the board, right, your soft board, we generally prefer the pins which are having a pointy tip, right? So it goes very easily with very less pressure. Why? Because the area in contact is less. So with less pressure, the pressure with little, you just push it and it enters inside. Are you getting this? Right? All right. Okay. So we have come to the end of today's session. It was wonderful to connect with all of you all in the comments, right? So I would want you all to all attend these lectures, right? So we can have wonderful discussions, right? So thank you for joining me today. We will be meeting again, all right, in the next session. My timing, generally I come at 7. You will get the notifications. So please do subscribe to Swiflearn. Press on the bell icon, you will get the notification. So whenever my lecture is going to be there, you will get the notification. Yes, Yashpal Singh, hello. Right, we are almost at the end of the session today, but please do subscribe and press the bell icon. Then you will always get the notification so before time, so you all can join me on time for my sessions, right? And we can have wonderful discussions on various concepts of science, right? So and do like and do comment also, and if you have any doubts in the comment section, do put it up. I will definitely answer your doubts. Okay, so that's all for today. Good night, and have a great time. Bye bye.